everyone. Welcome to episode number 566 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Folks, what a week I have had. I spent the good portion of last week at the Embedded Tech Trends Conference in mostly cloudy Fort Lauderdale, Florida. This conference is an industry-wide forum where suppliers of component, board, and system-level solutions meet industry media like myself to discuss technologies, trends, and products. And I have two interviews lined up from this year's show to share with you this week. My first guest is Simon Collins from Abaco, and we're talking all about enabling cutting-edge capabilities in open architecture systems, AI in defense applications, recent trends in RF performance in military and aerospace systems, and a whole lot more. Also this week, longtime friend of the show, Matt Burns from Samtec, joins me to talk about the system on module ecosystem, the benefits of SoMs and COMs, the trends that Matt is seeing in this space, and how Samtec is encouraging innovation in this arena. So first, please welcome Simon to Fish Fry. Hi, Simon. Thank you so much for joining me.
Hi, pleased to be here.
Excellent. Okay, so let's talk about enabling cutting-edge capabilities in open architecture systems. So first off, what kind of trends are you seeing in this space?
I think the main things we're seeing are ever-increasing performance from our technology partners, so the silicon vendors, and the higher levels of integration that they are able to bring in their components. That, when it translates into a board-level product, means that we're able to deliver products that have much greater performance generation on generation. And so our philosophy is to provide form, fit, and function so customers can easily upgrade. And part of the basis of that, the whole Vita open standards, building on that SOSA open standards, building on top of that CMOS host, MOSA. All of these things allow us to deliver greater performance each year, greater capabilities to our customers. So now customers are able to do things that even 5 years ago were unthinkable on a vehicle platform, whether that's a land vehicle, an aircraft, or marine. So the trend towards ever greater performance translates into ever greater capabilities for our customers.
Okay, so I was really interested, Simon, in AI in defense applications. So what are you seeing in this realm, and what challenges do you see AI helping to solve in the future?
So we're obviously seeing AI coming across from the commercial space. Really hot in the news right now is all the generative side that's really grabbed the public's attention. But one of the things AI is really good at is in detecting patterns in streams of data. So whether that's in streams of video data, or whether it's in streams of RF data, whether that's moving into the radar domain. Previously, what companies have had to do is have maths PhD, very theoretical endeavor to characterize what the event or the object within that stream might look like, and then model that in some high-level tool like MATLAB, and eventually hand that over to a programming team who'll go and try and implement it and then verify that it's doing what it was meant to. So the process of getting around that loop is very long. What AI is very good at is taking raw data, now that can be synthetic data, or that can be data that's taken off a real-world sensor on a real-world platform. AI is great at taking that data and, after some annotation of the data, really quickly training the model to pick out those events, those objects from the data stream. So from a practical perspective, if there is, for a vehicle, a particular threat that the crew need to be warned of, then it's entirely possible that the deployed platform will not recognize new threats. So what we're seeing is customers who are able then to take that sensor data, bring it back into the development loop, retrain the model really quickly, and redeploy the inference model back out to the edge. Instead of being maybe 6 to 9 months to get round a loop of upgrading the capability, that can get down into weeks. So it's a dramatic improvement in the speed of deployment.
Let's also talk about RF performance. What kind of trends are you seeing here?
Again, it's down to increased performance that our suppliers, our technology partners are able to deliver in terms of the silicon that we use. In terms of analog to digital performance, that's more samples per second, so much higher sampling rates, more channels, and more resolution of each sample. What that does is generate an enormous amount of data. So historically, the limiting factors were how you could move that data off the initial digitizer into the back end of the system. There are a lot of techniques for reducing that data, but at that point you're obviously losing some of the fidelity of the data. So we have a number of trends in terms of the bandwidth capability to move the data to other parts of the system, but we also have FPGA partners who are again delivering more performance each year, and therefore our customers are able to do much more sophisticated algorithms right up at the front end where the data is acquired, and actually providing information rather than raw data to the back end of the system.
So, Simon, high performance connectivity is also a critical component of these systems, right? So, what is Abaco in particular doing to address this issue?
So we're following, again, it's open standards, so PCI Express getting faster each generation. It is Ethernet, so Ethernet speeds going up, and the combination of PCI Express and Ethernet allows us to build systems where we're connecting the points that are generating the data more effectively to the computing resources that are applied to that, whether those resources are CPUs or GPUs, FPGAs, combinations of those three types of processing. So in addition to the core technologies, there are also improvements in connectors. So our Vita partners are improving connector signal integrity, which allows us to get these very, very high bandwidth signals through off cards, backplanes, back onto cards. And we're also moving to optical, so we're able to get 100 gig Ethernet over backplane to other cards, and then 100 gig Ethernet via optical out to other parts of the system and other systems within vehicles.
We should also talk about Ethernet as well, right? So, what kind of standards are affecting Ethernet switching in particular?
So I've mentioned 100 gig Ethernet. So we've moved to 100 gig Ethernet to really enable the highest performance systems. So typically in radar and electronic warfare, where the amount of data is vast. So 100 gig Ethernet is probably the main performance enhancement. But we're also seeing other trends. So in terms of segregating network traffic, for a long time we've been using VLANs, which allow the network to look like several networks. But in many applications, as we get this increased performance and increased integration of functions within a system, customers are demanding that we have physical separation between networks. So it's provable that the traffic can't pass from a secure to a non-secure part of the network. So we're seeing these multi-domain networks, and then within each network we're seeing the need for time-sensitive networking, TSN, and that really allows for dedicated bandwidth to be reserved for particular communicating channels. So we can guarantee that when part of the system needs to communicate to another part, that bandwidth is available and it isn't going to be swamped by other traffic from another channel. That's also that protecting the bandwidth, but also in terms of having dedicated time slots in which to transmit. Again, it guarantees the determinism of the system and reduces the latency, because you know that this channel is the only one that's going to be communicating at this time slot. So those are things that, again, with the sheer amount of data, allow systems designers to get to a level of performance, a level of determinism that customers are demanding in these systems.
Abaco has a quite robust portfolio when it comes to these types of systems. So, talk to me about that.
Yeah, so we have a very wide, very broad portfolio. We have domain experts in all of the technologies we've talked about here. whether that be processing, GPU and AI, into networking, into cooling. So with all this performance comes thermal power we have to dissipate off the system. So we have experts who spend all of their time trying to figure out how to make the thermals more efficient. If we remove the heat more efficiently, then we can run at a higher performance. And that ultimately is what our customers are looking for. So it's really the breadth of the product line that we have that enables our customers to be able to build these systems. Either they buy cards from us and they build the systems, or sometimes they come to us with a definition of a system, a set of requirements, and we build the system for them and deliver a complete system.
All right, Simon, it is time for your off the cuff question. So, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
Oh, that's a difficult one. There's so many things to choose from. I think I would have to go crispy duck. Crispy duck and pancakes, hoisin sauce. I think that's one of my favorites.
Oh, I love that answer. So good. I love crispy duck. Well, Simon, I think that's all I have time for today. Thank you so much for joining me.
Thank you.
Next, let's bring in the one, the only, Matt Burns from Samtec. Hi, Matt. Thank you so much for joining me.
Hey, Amelia, it's great to see you again.
It's great to see you too. Okay, so we're talking about the system on module ecosystem. But first, talk to me about the concepts here and the benefits that you're seeing in this space.
Amelia, that's a great question to start the conversation off. So in short, most of your listeners are going to know what a SOM is, system on module, computer on module. I tend to think of those terms as interchangeable. Some may argue whether we can do that or not, but I'll leave that to them to make that decision. In essence, it really comes down to a make or buy from a design standpoint. System on module is exactly what it sounds. It's an electronic-based system that has a compute engine of choice. Maybe it's x86, maybe it's ARM, maybe it's another CPU-based solution, or it's an FPGA, an RFSoC, a GPGPU, whatever the case may be. And it has all the necessary digital parts to make the system literally a single board computer. So that's going to include the RAM, that's going to include the flash, that's going to include the I/O, that's going to include the sensors, that's going to include the power. And the reason why more and more OEMs are looking to SOMs and COMs is because of the fact of quicker time to market, right? Typically, the SOM is going to save you anywhere from 12 to 18 months design time versus doing it discretely. Now the question comes up, should I do discrete or should I buy off the shelf for your computing needs? It really comes down to the OEM. If you need something fast to market and something that's standard and the price is right, you're going to save money in the long run. But if you're only doing small volumes, it may make sense to do something discrete. It's really a trade-off that the OEM is going to have to decide upon when looking at it. Some of the trends we're seeing in SOMs, faster, smaller, denser, all because of the fact that compute engines continue to follow those trends on a general basis.
So, what kind of solutions does Samtec have to support these trends?
That's another great question. This is a two-part question, right? In general, SOMs continue to get smaller. There are several solutions on the market that don't use connectors, right? You look at SMARC, you look at Q7, you look at the new OSM solutions that are coming from SGET. They're targeted for a specific application where cost is one that the overriding concerns. So there's that subset of SOMs. However, there's also another subset of system on modules that are focused on high-end, high performance, really keeping up with Moore's Law, other innovations based on, some of the other compute engines that we've seen, especially with the global takeover of AI. Maybe that's not the best way to say that because that may infer Ultron, but sorry, I love Marvel. All jokes aside, AI has definitely been a differentiator in the industry. So to run AI, it's hard to do that on an 8 or 16 or 32-bit MCU. You really need a GPGPU, an FPGA, a high-end x86 device. So to create a SOM for a compute engine that's supporting AI, it needs a little bit of heft, right? So when you look at some ecosystem solutions out there, again, two trends. One, you have the off-the-shelf solutions, COM-E, more recently COM-HPC. Not only are you supporting higher speed protocols, PCI 5, PCI 6, 100 gigabit Ethernet, 25 gigabit Ethernet, USB 4, et cetera, you'll also be able to support the power. So when looking at some of these higher performance SOMs, Samtec is really focused on developing high-speed, high-density, low-profile board-to-board connectors, mezzanine-style connectors, to support these next-generation SOM form factors that are going after those higher-end applications, whether that's the intelligent edge, server on a SOM, AI capabilities at the edge, et cetera, et cetera. not only do we offer the interconnects for some of the open systems like COM-HPC, but we also see a number of OEMs that have their own form factors targeting specific applications for those same solutions, right? The intelligent edge, AI, Industry 4.0, IoT, et cetera, et cetera. So that's where we focus on winning with SoMs, is the fact that we have the industry's largest portfolio of high-speed board-to-board interconnects, whether it's open source SoMs like COM-HPC or custom that we see a lot of OEMs designing for the market space.
Okay, so let's circle back to some of those applications you mentioned, like AI. We're talking about a serious amount of performance here. So, what COM solutions are you seeing that can keep up with the demands of these applications?
Well, we're a connector manufacturer, so I'm going to answer that question from a connector standpoint. We tend to be agnostic in terms of who our, the OEM customers use in terms of their compute engines, right? In a general sense, we're seeing obviously x86. We see continuous innovation there from Intel, AMD, some of the other providers there. ARM solutions continue to proliferate. TI and NXP and other leaders are there. We see FPGAs, obviously the two big players there, AMD, Intel, but there's other emerging players there as well. And you can't discount what NVIDIA's done with their GPUs. You look at the Jetson family of SoMs that NVIDIA has, and they really target the key markets. So those are the trends that we tend to see at a macro level. From Samtec's perspective, in terms of enabling performance, we tend to look at the channel data rates. So, some of these solutions want to support PCI 5. That automatically tells me 32 gigatransfers per second at the pin level. How do we support that? PCI 6, you're doubling that to 64 gigatransfer per second. USB 4, 40 gigabits per second, et cetera, et cetera. So from Samtec's perspective, in terms of how we're enabling COMs, is we're really good at making high-speed, high-density, low-profile mezzanine connectors. It's not only that, but it's also providing the design ecosystem to pick the right pin out, pick the right signal breakout, pick the right PCB material to make the solution at the SOM level and at the carrier card level work to get the signals from the compute engine on the SOM or COM through the connector down to the carrier card and out to the I/O connector.
So, we should also talk about COM-HPC as well, right?
Yes, the short answer is yes. But COM-HPC is really designed for server at the edge, which ties into the intelligent edge, which by extension to me is really, it's a great form factor, I think, that we're going to see for AI solutions at the edge. In reality, it's bringing data center performance into a more of an embedded application. Some of the key contributions about COM-HPC, the latest PICMIG COM-HPC 1.2 specification creates the COM-HPC mini module, which is very similar in size to some of the credit card size modules you see within COM-E and in some of the other embedded applications like Q7, SMARC, and OSM. But it has the performance advantages of COM-HPC because it uses the high-speed COM-HPC connector from Samtec that supports PCI 5, PCI 6, 100 gigabit Ethernet, USB 4. COM-HPC also is scalable because in addition to the COM-HPC mini module, there's 3 client modules, A, B, and C. Those sizes scale from A to B to C, obviously, and then you have the server on modules, which have D to E. If you use the mechanical hooks from the size A module, and you come up with one carrier card, you can scale the system over the years to increase the compute performance in the system without having to change the carrier card. It really becomes future-proof because of the flexibility and scalability of COM-HPC. And in reality, Amelia, COM-HPC is really at its infancy. COM-E has been on the market for almost 20 years, and people use COM-E like crazy. And with the new COM-E 3.1, which gets performance up to PCI 4, 16 gigatransfers per second, it's going to be around for another 5 to 10 years. I fully expect the COM-E is going to be around for another 10, 15, 20 years. Will it go through some revisions? Of course. Are there going to be new module sizes? Probably. And our goal is to support the connector performance long term.
All right, Matt, it's time for your off the cuff. So, if you could have a meal with someone right now, alive or dead, who would it be?
First of all, I have to say my wife, because if she hears that I don't say that, I'm a husband, you know the results. However, one person who I would love to have dinner with, who's no longer with us, is Malcolm X. People have different viewpoints of him. But one of the things that I liked about him, whether you believe with his philosophy on life or some of the messaging he had or not, is the fact how much he turned his life around. Even if all you know about Malcolm X is just the movie that Spike Lee put together 30 years ago, 32 years ago, believe it or not. The fact that he was such a hardened criminal, and then he turned his life around, did a complete 180 degrees, and became the person that he became and the influence that he has even to today. I think it'd be really cool to have a meal with him to help me understand what was it that made him see that he needed to make that pivot in life. He'd be a cool guy to meet.
I love that answer. Well, Matt, it is always a pleasure speaking with you. Thank you so much for joining me.
It's always good to see you, Amelia. Thank you so much, and I wish you future success on all your endeavors.
Embedded Tech Trends is one of my favorite conferences every year. Why? Well, I think it boils down to the dedication to open standards. The idea that we're working together toward common goals. Every year, I am encouraged by the critical thinking, the quality interaction, and innovation that is on display at this show. I would like to give a big thank you to Dean Holman, Jerry Gipper, and Jing Kwok, who help put on this show every year. I will be rolling out even more interviews from this conference, including discussions about the advancements in direct RF, supply chain resilience, how artificial intelligence can be used to enable decision superiority, and a whole lot more. So, if you haven't already, make sure you subscribe to this here podcast on Spotify, Google Podcasts, Podbean, Apple Podcasts, YouTube, or just about any other podcasting platform to listen to these exciting upcoming episodes. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into X, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn as well. We are also on Blue Sky Social and Mastodon too. And we have a YouTube channel, youtube.com/EE Journal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me. And of course, you can subscribe to our EE Journal YouTube channel as well. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of January 26th, 2024, I'm Amelia Dalton, and you've been fried.